let's look at actin microfilaments. So these are made up of little globular pieces of actin, that's the monomer, and then when they combine, they have these two strings that are kind of coiled together, and it gives you actually the filament with the thinnest diameter of the three that we've been talking about. And this creates your microfilament. Now this one, like microtubules, is also polarized in that it has a minus end and a plus end. Now you can add this globular actin at the plus end or the minus end. It's faster to add them at the plus end, so that's usually where you would do it. Okay, so why is this useful? Well, if we look at microvilli, not to be confused with cilia, ciliated cells, cilia, first of all, are made up of microtubules, and they move. So those would be like, say, in your respiratory tract, to be able to move the mucus within your lungs so that you can keep breathing properly. Now, if we look at the microvilli, those would be, say, in your intestinal tract, and these don't move. These just have actin to help give them their shape, and in the GI tract, they're just increasing surface area to increase absorption. Actin microfilaments are also important for just generally keeping cell shape. They also play an important role in cytokinesis when you're trying to split a cell into two after mitosis. And then they're also really important in cell movement. So say you had a cell that doesn't have cilia or flagella, so it can't swim if it wants to move. Say maybe it could be an amoeba or a white blood cell, and it's trying to crawl on the surface. Well, it needs these actin microfilaments. So what it does is all the globular actin within the cell is going to move towards the front of wherever direction you want to be moving in, and then they start to add on to the plus side of actin, polymerizing it so that it grows towards the front in this part called the lamellipodium, and then it pushes the cell more towards that direction, and then after that it anchors into whatever surface it's crawling on, and then it kind of contracts the back, and actin helps pull it forward. But to be able to do that kind of contraction, and also during cytokinesis to have that contractile ring, actin doesn't work alone. It needs the help of this motor protein called myosin. Myosin is a motor protein that only interacts with actin. It can be used for cell movement, like we talked about in crawling. It's also used in the pinching of the cytosol to break off into two daughter cells during cytokinesis. And then it is also famous for its role in muscle contraction. Actually, myosin and actin were discovered in muscle cells, but now actin is known to be in all animal cells, and it's actually the most abundant protein in animal cells. And then we also have myosin can also help in vesicle and organelle transport.